All right, we're going to examine linear equations in two variables, but we're going to look at the slope-intercept form of those types of equations in particular. So let me remind you what a linear equation in two variables is. A linear equation in two variables is usually written in terms of x and y, and x is to the first power, y is to the first power. That's what makes it linear. And since they're to the first power, the graph is a line. Okay. Now, these equations can be written in all kinds of different forms. X and y can be on the left or the right side. There could be multiple x's and y's that could be combined if you wanted to. But what we're going to look at is what's called the slope-intercept form of this equation. And if we solve, excuse me, if we solve the equation, whatever it may be, for y, we get what's called the slope-intercept form of the equation. And that looks like this. It looks like y equals mx plus b. That's the pretty standard way to write the slope-intercept form of a linear equation in two variables. You can see that this equation has x and y, but it also has these other letters, m and b. Okay, so let's talk about those for a moment. So in this equation, notice that y is by itself. We already said that. That's what's key. Y has to be by itself. X and y are the variables. Okay, so x and y are still the variables. They can change. In fact, what do they represent? They could be any ordered pair on the line. Okay, so x and y can change. They vary. So what does that tell us about m and b? M and b are constants. And what that means is they are fixed numbers that don't change. Okay, so they are specific numbers. Usually, sometimes you have to figure them out. Sometimes they're given. It just depends, okay, depending on the example. All right, and as we already know, m is the slope. So in this equation, m is the slope, and it is always the number multiplied by x. And that has to do with this equation being solved for y. Um, what you do to calculate a y value on a line is you multiply the x value by your slope in general. Okay. Now the plus b part of this, that's going to have a different effect. So the slope is multiplied by the variable x. B is the value where the graph crosses the y-axis. Okay, so we give this a name. It's called the Y-intercept. So that means the ordered pair, because intercepts are points or ordered pairs. So the ordered pair 0, b is the Y-intercept of the line. So this name, slope-intercept form, is very telling. So the slope, well, that comes from m. M is the slope. It's always multiplied by x. Intercept, we have to know that this means y-intercept, comes from the b value. So 0b, 0, b is the y-intercept. Slope-intercept form. Okay, let's look at why 0, b is the y-intercept. If we take the equation y equals mx plus b, and remember, to find a y-intercept, you always plug 0 in for x. Then we get y equals the slope m times 0 plus b. Well, m times 0 is 0, and 0 plus b is b. So we can see that the y-coordinate is b, and the x, of course, is 0 since it's a y-intercept. So if you plug in 0 for x, you can still calculate your y-intercept like always, but it's very easy to know that the y-intercept comes from the b value. Okay, let's look at some examples of using this form of the equation. Y equals 4/3 x minus 7. So this is y equals a number times x plus a b value. Now your b value can be negative, so it can look like a minus. So m, your slope, is 4/3. Your b is -7. So we have our slope. -7 is not the y-intercept, but the ordered pair 0, -7 is the y-intercept. That's all there is to it. That's how you find your slope and y-intercept. That's why this form is useful. You can get useful information about it just by looking at the equation without doing any work. Now we're going to look at a couple tricky examples. Determine the slope and y-intercept of each. So if I give you the equation y equals 2, that'll be one of the examples we'll look at. The other equation, maybe x equals 2. This equation, if you want it as y equals mx plus b, you could think about it as being, since there's no x here, you could say 0x, because 0 times x is 0 plus 2, right? It's kind of a weird way to think about it, but 0 times x is 0, 0 plus 2 is 2, so this is still the same equation. So our slope, m, would be 0, and the ordered pair 0, 2 is the y-intercept. Now, we also know this is a horizontal line. That crosses the y-axis at 2. So if I were to graph the line, it would look like this. Let's say this is 2 on the y-axis. It would look like this. And we know the slope of a horizontal line is 0 because the rise is 0. And we can also see that the y-intercept is 0, 2, which is what we said above. Okay, let's look at this other example. In this case, if I want it in slope-intercept form, I can't even put it in slope-intercept form. The reason for that is we can't solve for y. We can't get y by itself. Okay, so we have to use other things to figure this out. Well, x equals 2 is a vertical line. Crosses the x-axis at 2. So I locate 2 on the x-axis, and this is the line that we have. And we know that the slope of a vertical line, since the run is 0, is undefined. And we can see there is no y-intercept because it does not cross the y-axis. Okay, so those are a couple strange examples, but if you have a y and an x, which most linear equations in two variables has, then you can always get y by itself, and then once you've done that, you can easily identify your slope and y-intercept.